Good evening, everybody. My name is Ashiff Khan. So I'm working in Saudi Aramco in Saudi Arabia, and I'm also working in a student in Jain School of Global Management, Australia. So today I will be presenting about adoption of big data by global chemical industries. So before I start, a few interesting facts about big data in chemical industries. Chemical industries, as you know, we hold a large amount of data. Data is not new to chemical industries, and this data is produced by several hundred to thousands of sensors in the chemical industry, such as pressure transmitters, temperature transmitters, flow transmitters, and also from analyzers such as product quality analyzers and other soft sensors in the facility. We also use a lot of process controls like closed loop, open loops, and a lot of this data is actually saved in the historian for future users. Also, the best application where we can see the use of big data and analytics in chemical industry is to walk through in a control room. So if you go into a control room, you can see operators continuously using this data for decision making, either as numbers or as trends. And they also used to mix different kinds of chemicals to get the right product or to change the specification and to use dosing of the chemical. So data and data analytics is not new in chemical industry. So what makes it important for chemical industries to transform into a smart industry is very simple. Actually, what we need is actually a change from the conventional approach that what we are doing now into a data-driven approach. And this change should be done in a very systematic way so that we can get the full benefit of big data from chemical industries. So in this presentation, I will be sharing 5 key variables that affects big data adoption in chemical industries, and also some sub variables that influence the main variables. And let me start with the most important one, which is professional competencies. So the professionals in chemical industries, what they require is additional technical competencies to invest their domain knowledge, to interpret the large amount of big data, and to make strategic decisions for the industry. So when I speak about professional competencies, the first one will be for the demand for skills and expertise. So as you know that employers, when they hire new engineers or new professionals, they look for their domain expertise in 1 or 2 discipline areas, which we know, which we mention as the depth of the knowledge. And they wish that these hired people, they have a wide range of knowledge in different subjects. So actually professional competencies falls under the wide range of knowledge in big data adoption. The second one is about management commitment. There is several literatures indicate that top management commitment, there is a strong positive effect in professional competencies for the adoption of big data. There is a lot of management commitment in adoption of big data technologies. However, there is a limited understanding about how firms can translate these technologies into business values due to lack of professional competencies within the organizations. What it is seen is management who promote innovations in process as well as innovations in different aspects of organization favor the development capabilities in big data analytics. The next factor that affects professional competencies is organization readiness. The organization readiness here, what I mean is the relation between professionals and their competencies with processes, systems, and performance measurement. Big data as such is a new process or a new system that is introduced into chemical industry. So therefore, lack of synchronization and lack of coordination of organization readiness with professional competencies affect the implementation of adopt big data in chemical industries. When I speak about professional competencies, one of the key factors is training programs, and that depends upon HR. Actually, the IR should depend on HR. HR practices play a significant role in meeting the principles of big data adoption by improving professional competencies. The HR practices here, I mean knowledge management, policy making, training, recruiting, reward system, job design, etc. Actually, when it comes to these kind of technologies like big data, HR should try to integrate between human, that's professional, and their competencies with such new with such new technologies, and also with the organization as such. The last one is about the job demand. So job demand here, I mean, I will share as an example that when students are hired from universities, they are good in their domain knowledge, but they lack critical skills. So for the professionals working in chemical industries, when such new technologies are introduced, what they lack is actually this kind of critical skills. So when the job demand is very crucial when development of professional competencies, professionals need not be trained in all the activities that is happening in the chemical industries. They just need to be very selective in the type of the job that they are handling, so that the efficient use of big data adoption can be maximized. The next variable that I would like to speak is about business intelligence. The business intelligence, here I refer to the procedural and technical infrastructure which collects, stores, and analyze the data produced from the company's activities. And when I say analyze, analytical capability becomes very important. So as I already mentioned in my first few slides, analytical capability is not new in chemical industries, but there is a gap. That's what is seen in the analytical capabilities is when professionals join chemical industries, they are good in the descriptive analytics, especially using dashboards. Very rarely we have seen people using prescriptive analysis, and predictive analysis is very, very rare. So in terms of maximizing the benefit of business intelligence from the big data, the predictive analytics capabilities of professionals working in the chemical industries is very important. The next two I would like to speak together about it, which is industry type and company size. Usually it is seen that the big companies tend to adopt big data very faster. This is because they can take quite a bit of risk in such kind of activities. But in case of developing countries, micro and small and medium scale industries, they become an important part of the economy. And therefore, the potential of big data in such small scale industries needs to be further explored. And in order to do that, the business intelligence infrastructure within those companies needs to be fully developed. The next factor that affects big data adoption in terms of business intelligence is the ease of use. Because when you use quite a lot of big data, it is very likely that the problems that comes out of the business intelligence, they may be unknown problems or maybe deep technical problems. So this will be kind of a surprise for the management. And therefore, all the highlights that is coming out of big data adoption through business intelligence should be there should be ease of understanding as well as ease of use in decision-making process. The last one I would like to speak is about the decision making itself. What is important for decision making is the information itself. As decision making process becomes very complex, we expect that the process will become a mixture of human and computer factors through big data and big data analytics. So there is still a long way of in business intelligence to use predictive analytics using big data, and to use that for the decision making purposes. It is expected that in future the managers and top decision makers will use continuous and real-time data to make predictive analytics and to make good decision, and they will use these kind of tools from the business intelligence to identify the impact of their decisions as part of big data adoption. The third factor, excuse me, third factor that I would like to speak about is about data scalability. Data scalability is the measure of systems' ability to increase or decrease in performance in response to changes in application and systems processing demands. This is a very rarely used term within the chemical industry, and usually it is handled by IT or software engineers. But because big data is becoming an important part in the chemical industries, these terminologies needs to be familiar with the professionals working in the industry. So one example that I can share is if this is something that we have seen quite a lot of chemical industries, that if an engineer is asked to download data for past 5 years every minute from maybe thousands of sensors, then his laptop or the PC that he used cannot be used for such activities. So this directly impacts adoption of big data by the professionals for decision making purposes. Therefore, data scalability is one of the key factor in chemical industries. So one of the key factor of big data is the complexity, because big data itself is a complex problem to be handled. There is wide range of scalable techniques which is available, and these scalable techniques brings additional problem into big data adoption. Uh, as I mentioned, the scalable techniques here I mentioned is about the large size of data, speed of data processing, data noise, data complexity, and data mining, data analysis. There are different types of scaling techniques. Usually, in order to avoid the risk, the better way is to go through a third party. But even if even if industry try to go to a third party to use technologies such as cloud computing and other new technologies, it is very important that all this business transaction should bring possible knowledge into the industry so that we can benefit from big data over a long period of time. The third factor is about capacity, because when these models or algorithms are used in order to solve these predictive problems, these models tend to outgrow the capacity. So there is a need for rapidly increasing and decreasing the capacity of data within the chemical industries, and usually third party is one of the factor that is considered. However, cybersecurity is one of the important things to be considered whenever a third party is adopted for this kind of technologies. The next one is about the user experience, because understanding big data experience will be the key for predicting users' future interests in terms of big data adoption. The task will be even more problematic because of the continual co-evolving nature of algorithm with humans, simultaneously developing new models, interacting with each other and developing new patterns. These algorithms that are user-centered and trust-based feedback is very important to improve the experience of users in adoption of the big data. The last one I would like to speak about data scalability is about data-driven deployments. Usually data should be easily findable, easily accessible, interoperable, and reusable to serve the interest of the industrial communities. Proper infrastructures are crucial to ensure the level of quality, security, and reliability. Cybersecurity, privacy preserving mechanisms, new technologies, and other collaborative technologies. Moving on to one of the important factors, which is process monitoring. The key variable that affects process monitoring in adoption of big data is the performance. Big data is not a better data. Actually, it comes with a lot of noisy data. So focusing just on collecting large amount of data in order to improve the processes in the chemical industry will not enhance the performance. There should be a good integration between all the data that is collected within the chemical industry with other kind of systems, such as SAPs or financial systems or other systems which is existing in the chemical industry. Usually one system can develop only a certain characteristic, and it can give some kind of performance, but integrating it with another systems can actually improve the overall performance of big data in terms of process monitoring. The next one is about real-time operations. Real-time tracking allows users to access information first, which in turn makes decision faster and outperforms the competitors. Real-time operation and optimal control is very important. Detecting the change in real time is a very critical task in terms of big data adoption. Organizations need to identify these change points, identify the threats in real time, prioritize them, and also to make optimal decisions in order to improve the processes which is happening within the chemical industry. The next one is about the algorithms. The excellent performance of algorithm in any one of the application may not be good in other application. For example, if an algorithm is developed to improve the performance of a distillation column, it cannot be used in some other distillation column because that contains another set of data. So it is very important to develop algorithms specific to each processes so that the process monitoring, predictive analytics from process becomes very efficient. The next one is about accuracy. Accuracy plays a very key role in process industries. One of the key factors that we have seen in terms of accuracies is the time shift. Maybe I'd like to share an example. Like when we use the Google map, for example, if the Google map says that in order to move from a point A to B, it takes 60 minutes. And when you travel all the way, it takes 61 minutes or 59 minutes, because during the journey, you either increase your speed or decrease your speed because you take control of the entire process. The same applies here in case of big data adoption. Suppose if you are feeding there is two feed streams, and the model predicts that the specification of the product will be on spec because of the nature of the feed in. And during the residence time within the process, the operator tends to make some changes, or some instruments goes malfunction, and the product may become off spec because of those things. So this is an accuracy problem because of the time shift issue that's happening from the inlet to the outlet. The accuracies of the model tend to get impacted significantly from the big data. So this is one of the key factors, that the accuracies needs to be improved quite a lot in terms of process monitoring, so that the false positives and false negatives from the models are avoided. The last one I would like to speak is about smart operations. The smart operations here, what I mean here is, by the adoption of big data, the centrally managed manufacturing process will be replaced by decentralized control. Decentralized controls here I means machines, robots, tools, intelligence workplaces, soft algorithms, all of them talking to each other, collaborating with each other, coming up with optimum solutions to improve the overall process of the overall process. Smart factories tend to be competitive because they are self-organizing, self-optimizing, and self-adapting to new situations and conditions. Moving on to the last one, which is investments in the tool. Investment decisions usually refers to investment decision made by the investor after investigation, analysis, and demonstration of the project. Therefore, how to realize accurate analysis of investment is very important when it comes to big data adoption. Investing in technologies where innovation capable can be enhanced can somehow reduce that risk. However, there is still a lot of studies needs to be done in choosing the right type of investment tools in big data adoption. Some of the factors that affects is like the stakeholders, because there are a lot of vendors and a lot of suppliers coming up with new technologies. So by the time an organization decides to make an investment in particular technology, and the organization completes its full deployment, some other new technologies comes and make you better accuracies and better process control because of that. Therefore, investment in tools in big data is a key thing, and organizations needs to be very careful about the changes that is happening across the industry, the rules that is coming from the government, especially in terms of cyber security and privacy issues, and type of knowledge and curriculum that is given in the universities. The second factor that affects the investment in tools is the firm's performance, because one of the key thing here is in order to improve the performance through big data adoption, investment should come first. And therefore, if for the firms which is struggling, actually, such kind of investments actually will be very difficult, even if it tends to give some potential benefits. So there should be a very calculated analysis that should be done in deciding the right type of investment tools to improve the firm's performance. And one of the key things that is required here is having a good digital business models. Decision making for digital investments is a very tough task, and it's a very critical task as well. This is because it is very hard to think outside the traditional industry boundaries. I already mentioned about a lot of developments that is happening within the vendors and within researchers that can improve such kind of new tools, especially in big data adoption. And also there is a kind lack of systematic tools that helps decision makers in order to choose the right type of investment, especially coming to these kind of new technologies, because it doesn't happen like a normal conventional project. And also these investment tend to be high risky, And it is very difficult to predict what will be the rate of return for such kind of investments, especially in big data adoption, until the real benefits are realized. So one of the key things that can be thought about is to see how much value can be created from investment of tools in big data adoption. It is very good to focus on the performance of the firms. So for performance here, I mean financial performance, or performance in the market with the competitors, or even with the customer satisfaction. When it comes to investment, as I already mentioned, risk is a very key factor, because knowing what will be the return of investment for such kind of big data tools or AI tools is very difficult task. People don't know before they invest how much returns will be there, because it's still at the infancy stage. So this risk needs to be studied, and they needs to be carefully managed before investing in tools, especially when going for such new technologies. This is the overall framework that I just presented right now, and before I move directly to the conclusion. So what I would like to conclude here is a systematic approach should be there in chemical industry to achieve the digital transformation. That is the shift from the conventional way of thinking to a data-driven approach, using this kind of new technologies such as big data. Developing employee skills, especially in big data analytics, and that too in predictive analytics, is very important. The domain knowledge should remain there as domain knowledge, and predictive analytics and big data analytics professional competencies needs to be improved. Digital transformation should align towards business intelligence and decision making, because that's the key part here. Knowing the right trends at the right time and the real time is very important to make the right decisions, and therefore all this kind of digital transformation effort should be linked to business intelligence. There is a need to focus on data scalability, because data scalability is not a term which is very commonly used in chemical industry, and especially except the IT engineers or software engineers, this term are not used by the other core engineers. So therefore a good focus is required on data scalability, how to ramp up and ramp down data capacity within the industry, not just to collect the data from all these sensors, but to use all these algorithms and all this complex regression and multivariate analysis to arrive at right decisions. There should be a shift from conventional process monitoring to statistical process monitoring, because conventional process monitoring is just based on experience. If you go, as I mentioned, if you go to a control room, the operator uses experience for process monitoring and process control. That should be changed into statistical process monitoring using regression analysis or decision trees or deep learning. Even there are organizations that those use deep learning for to know the type of the product quality. So there should be a very good shift that should happen from conventional process monitoring to statistical process monitoring. And lastly, investment in tools and technologies is very important to develop smart industries, because smart industries is investing only in data collection is not going to help. Actually, the investing in data is one part, and integrating all the different kind of technologies so that they can talk to each other and they can come up with smart decisions. This is very important. So the tools and technologies need to be selected in such a way that the entire industry, the entire operation can be turned into smart operations. That's all from my side. I would also like to thank Dr. A. Sitaraman and Dr. Abhijit Das Gupta from SP Jain University who helped me in this presentation. And that's all from my side. And thank you very much if you have any questions.